Hi everyone, and welcome to part 1 of this formal logic video series. In this session I'm going to talk about metavariables and well-formed formulas. So what I'd like to do is just first of all go through some definitions so that we're all on the same page. Then I'm going to go through the rules for generating well-formed formulas in the logical language that we'll be using in the first half of this course. And then finally I'm going to look at a few exercises where we can see these rules in action. So, first of all, as many of you know, we begin this course by looking at a language called PL, or propositional logic. Sometimes called the propositional calculus. Now we will move on at some point to look at a more advanced language called QL, or quantified predicate logic. But for the time being we're just going to look at this more basic version and get to grips with that, because QL is really just a development of PL. Now PL is a very simple language. It has very few symbols for us to learn and very few rules for using it. Now the symbols that we use, first of all the semantic content of our language is dealt with by sentence letters. So we use uppercase letters from the Roman alphabet, A, B, C, D, all the way to Z, and we can also add subscript numbers in order to generate more sentence letters. So A1, A2, A3, all the way to AN are all sentence letters that we can make use of, and of course also we could have B1, B2, B3, all the way to BN, and the same for every other letter of the Roman alphabet. So we've got an infinite number of sentence letters to play with. We also have the following connective symbols. We have this tilde, the caret, vel, hook, and the triple bar, and these can be used to join together different sentence letters to form larger formulas of PL. And then finally we have an open bracket and a closed bracket that we use as punctuation. So starting with our sentence letters, or let's first say just that a formula of PL is any string of the above symbols. And a special kind of formula is an atomic formula. An atomic formula is just where we just have one symbol, so just one of these sentence letters. So, for instance, A on its own would be an atomic formula. Right? It's the simplest kind of formula that we could possibly have in PL. And of course every other sentence letter in isolation would be an atomic formula. Now as for the longer strings of these symbols, we don't just want any of them, like not any of them are going to do. Just as in English, although there's lots of different words and they can be put in different strings to form sentences, not all sentences are grammatical, or we might say well-formed. So John is happy looks like it's well-formed in English, but happy John is, although it might be thought of as a sentence, isn't a well-formed sentence of English. And that's because it doesn't conform to the grammatical rules of the English language. Well, similarly, a well-formed formula of PL is one that conforms to the rules of PL. So in order to know whether something is well formed, we just need to know what the rules of generating formulas are in PL, what those rules are. And being a very basic language, very simple language, there's only 3 rules for generating well-formed formulas. Now, what we could do in order to say what the well-formed formulas are of our language is just to list them all. We could just say, well, any atomic formula is A, B, C, D, all the way to the last sentence letter we could have, and then we could also list all of the, not A would be well-formed, not B, not C, not D, and so on, A and B, A and C. We could just go through and try and list every single formula that we want to say is well formed. Now, problem with this is that there's an infinite number of symbols, so it's not possible for us to actually do this. Instead, what we're going to do is we're going to cheat. We're going to state our rules using what we call metavariables. And the metavariables that we'll use are the Greek letter phi and the Greek letter psi. Now, phi and psi are not a part of PL. That's a really important thing to remember. But we can use them to talk about PL. These metavariables can operate in much the same way that mathematical variables operate, right? When we have 2x equals 8, we know that variables in maths and these kind of equations stand for numbers. So in this case, x stands for 4. Our metavariables are very similar, except what we'll do is say that these can stand for formulas of PL. So these can stand for strings of symbols, but because they can stand for any string of symbols whatever, we can use them to talk about all the different kinds of formulas we want to lay out. Yeah. If we were to just say A caret B is a well-formed formula, this just doesn't say anything about, say, A caret C. So there would be our problem with stating it just in the sentence letters that we have. The use of metavariables, as we'll now see, can allow us to state the rules of PL without mentioning any of the sentence letters of PL itself, themselves. So, a very simple language, only 3 rules. So first of all, rule 1, say for any phi, if phi is an atomic formula, then phi is a well-formed formula. Right, so our atomic formulas, remember, are just where we have a single sentence letter on its own. So any single letter just on its own with we need nothing else, we don't need any brackets, any punctuation, just the sentence letter itself in isolation is a well-formed formula of PL. Okay. Now our second rule, we're going to need 2 variables, so we'll say for any phi and any psi, if phi and psi are well-formed formulas, or wffs, then tilde phi, phi caret psi, phi vel psi, phi hook psi, and phi triple bar psi, all of these are well-formed formulas of PL. So there's our second rule. So this gives us 5 different ways of modifying any well-formed formula. Remember that phi and psi here can stand for any well-formed formula of PL. We can now modify them with these symbols, but only in these ways. Right? These are the only ways that have been stated. And so then our final rule, the most important, is there are no more well-formed formulas. So whatever it is, whatever we can generate with these rules here, with 1 and 2, that's it. There's no more well-formed formulas of PL. Now let's just look a little bit more about the use of phi and psi in these rules. The great thing about them is that if we were to take, suppose that we have just a sentence letter, A, and we want to make a well-formed formula. Well, it's already a well-formed formula, but suppose we now want to add on a tilde. We know that that's well-formed because our rule above says that for any phi, if phi is a well-formed formula, then not phi is a well-formed formula. But what this shows us is that not A is well-formed, and so phi could stand for not A. Right? We could say phi is not A, in which case, again by this rule, if phi is well-formed, then not phi is well-formed. Not A would be a well-formed formula. And as that's a well-formed formula, we could add not another negation, not A, and again that would be a well-formed formula. And that's just being generated by these rules here. Similarly, if we have an extremely long formula, we could have this represented by phi. Phi can stand for this whole, this longer string of symbols. So because we know that phi then psi in brackets is a well-formed formula, suppose in this case that psi stands for F, we know that A or B, then C, then F is a well-formed formula because it has the right structure here. Right, we've got phi standing for A or B, then C. That's this bit here. We need outer brackets so we can see. Here those are. And we've got then psi, and we said that psi in here stood for F. So we can generate lots of different formulas, and the metavariables are useful in that they can stand for just any formula at all. And so in that way, again, we don't need to state all of the different individual formulas that are well formed. We can just rely on the use of the metavariables to do that for us. Okay, so these rules are very important, and they tell us everything that we need to know about writing in PL. And now let's just look at a few different examples of maybe what we'll think of as violations of these rules. At a more basic level, sometimes we'll see things written like this. A, caret B, we read this A and B, but without brackets. We might write this sometimes. Also, we'll skip the outer brackets on formulas. So we might have A and B and C. The reason being that there's no ambiguity introduced by writing things in this way. It's still clear that this is the conjunction of A and B we're talking about. With this second case, if we had A and B, then C, with no brackets, we might think, well, it's not clear whether we're talking about A and B, the conjunction of these two, implying C, or that we're asserting jointly asserting A and that B implies C. So here we need brackets in order to show what we're saying, to make things unambiguous. But again, why do we need to add these outer brackets? In these cases, it's just not ambiguous. There's no ambiguity introduced by dropping those. Might say no ambiguity. And that's perfectly true, and we will relax these rules to write in this way. But the fact that that these aren't ambiguous doesn't mean that they're well formed. We should take note that unambiguity does not equal something's being a well formed formula. So, although the way that these rules are structured, the fact that we can only generate formulas with brackets around them and one operator, although that means that every well-formed formula is unambiguous, it doesn't mean that every unambiguous formula is well-formed. And that's just a direct parallel to the way that in English, say, look, hear what I've written. I've got no capital letter at the beginning of this sentence. I've got no full stop at the end. We might even think that just no ambiguity on its own isn't well formed anyway. We might need to say something like, there is no ambiguity here, or something like that. We might need those additions in order for them to be well formed, a well formed sentence of English. But nonetheless, no ambiguity in an arrow is useful. It's just not a well formed sentence of English. So again here, although these are very useful ways of writing, it's useful to drop the outer brackets. It's a lot quicker when we're writing, and there's no ambiguity introduced. They're not well-formed formulas of PL. Another case of something's not being ambiguous, but it's nonetheless not being well-formed. Suppose we have A in brackets, caret B, or A and B. Now we might think, look, the extra pair of brackets here are kind of superfluous. They don't do any work because A is a well-formed formula on its own. But again, there's no ambiguity introduced here. Well, what we need to ask ourselves as to whether this is well-formed is whether we can generate it with the rules above. Well, look, if we were going to write this formula down, if we were going to create this, we'd start off with an A and a B, but at some point this A has got to go to an A in brackets. But there's just no rule for doing that. Right? We have, for any phi, if phi is an atomic formula, then it's well formed. Well, A is an atomic formula, so that's well formed. And then for any well-formed formula, the following are well-formed formulas. And these are the only 5 combinations. At no point is there phi in brackets. Yeah, we just don't have that here. So, because of rule 3 saying there are no more well-formed formulas, this is not a well-formed formula. And so, therefore, we wouldn't be able to generate this, because this isn't a valid symbol that we could use to construct it. So again, we've got something which is unambiguous, but nonetheless is not a well-formed formula. Okay, finally, before we move on to some slightly more complicated examples, it's tempting when we begin and we use the tilde to think that we need to bracket, we need brackets to show what the tilde is applying to. So sometimes we'll have a tilde next to an A in brackets, or we might have brackets round the negation, the tilde in the A. Now our rule for introducing a tilde is just that if phi is a well-formed formula, then not phi is a well-formed formula. And there's no brackets involved here at all. The tilde as an operator just applies to whichever formula is directly next to it. Now the worry might come in when we have something like this. Let's say we've got that. Now your worry might be, this is currently ambiguous because it's not clear whether the tilde is applying to just the A or to the conjunction of A and B. But actually that is clear because a tilde always just applies to the formula directly to its right, and A on its own is a well-formed formula, so this can only be read as the conjunction of not A and B. If we wanted to make it the negation of the conjunction of A and B, we'd need to add in some brackets here. But in that case, once we've done that, we could get rid of these outer brackets. Our rule doesn't tell us to add brackets around our negation in the same way as it did with, when we've got this. That's right, we never see brackets around a negation being applied because it's unambiguous, and the way that it works is just to apply to the formula directly to its right. So these two, negation and then just a formula in brackets, a atomic formula in brackets, or a negated formula in brackets itself, we never need to do that. Okay, now let's look at a few longer strings to see what might be wrong with them and how we might go about doing that. Well, if we just look at this, presumably we can already see some of the violations that I just talked about above. So, for instance, here we've got a negation of an atomic formula within brackets. And as we saw just here, we don't ever do that. Right? We don't need to do that. That's not well formed. That's not the way that the application of the negation symbol works. Again here, we've got an uneven number of brackets, we might note. We've got 1, 2, 3 left-hand brackets, but then only, and then 1, 2, 3, 4 right-hand brackets. So something's obviously gone wrong there because we can't have a different number of left and right-hand brackets. There's no point in any of these rules do we see an open bracket and then no closed bracket, or vice versa. Right? There's nothing like that. So we're always going to need to have the same number of left and right-hand brackets, and that's going to also cause some problems in how we read this. Do we read this as the negation of this bracket here? So is this negation this, or is this the negation of here to the very last bracket? So the inclusion of this and no other without another left open bracket means that it's not clear how we're supposed to read this sentence. Now, if it is that this, if it should be read as not, if it is that it applies to, it ends here, well, again we've got a negated well-formed formula in a bracket. We've got something like this. If we allow phi to stand for this bracket here, we've got something similar going on that we saw, and again it's at the end here, so we know that that must be wrong. So we could just remove these outer brackets and just have not A or B or C. Now, hopefully, obviously, you've already picked up that this A or B or C is also not well formed. We can't have brackets with more than one operator in them because it's not clear which one we need to do first. So what we need to do to sort this out is add in another bracket just to, B or B, just to show which of these operators was the main operator of this sentence and which was subordinate to it. Now once we've sorted that out, we're still going to end up with some problems. So let's suppose that we removed the brackets from not D, and then let's rewrite, and we've added some in here. We're going to end up with not A or B or C, and C if and only if not D. Now we've still got a problem here because let's use our metavariables again. Let's allow this bracket A or B or C, let's allow that to be phi. In fact, let's allow phi to range over these two negations as well. So remember, these negations are applying only to this bracket, not to the whole thing, unless we add in some other brackets to show that. So let's allow that to be phi. C is an atomic formula, so we'll just leave that as it is. Not D, let's allow that to be psi. What we would have, if we wrote that out with those variables, is phi and C if and only if psi. And then we've got a closed bracket. So already we can see we need another open bracket here, presumably at the beginning. But even if we do that, we've again got two logical constants operators within one bracket. So we're going to need, again, we could do it either way, but let's just put it this way. We're going to need a bracket around these two bits, around the C and the formula represented here by psi. So, rewriting with that in mind, we're going to get the following. Not A or B or C, and bracket C if and only if not D. Close bracket. And now we've turned this non-well-formed formula into a well-formed one. Okay. Let's move on to look at another example. So here, unlike the first one that we looked at, we've got 1, 2, 3, 4, 5 left brackets and 1, 2, 3, 4, 5 right-hand brackets. So just by counting brackets alone, we can't tell whether this is well formed or not. Though by just having a quick look, we can see that it isn't. Note that this A and A actually turns out to be well formed. Some people stumble on this and think that if we were to have phi and phi, because we don't see that in our rules, we rather have phi and psi. There's a thought that we can't have the same sentence letter put forward in conjunction with itself. They need to be different. But remember, these are metavariables, so they can stand for any formula of PL, even they can both stand for the same formula. So this actually is well formed, A and A. The problems begin when we start looking at, say, this particular part. Let's just pick that out. So we'd have not C, like that. Now, again, in order to we couldn't generate this with the rules that we have. Right? If we had C, there's no way of getting to a C in brackets. And we've also got this, if we allow the negation of C in brackets, if that were phi, we wouldn't be able to get to this extra set of brackets around it again. We'd just get to not phi, which would be not C. Right, so to sort this out, what we need to do is get rid of these brackets entirely, and we just end up with not C to resolve that. Now if we do a bit of rewriting, we'll have G or F if and only if A and A, if and only if not C or G, close bracket. Oh, sorry, I've taken off one too many brackets there, so there should have been another one there. Okay, now let's break this down a bit more. So let's look at just this inner bracket here, from here to here. F and not C are both well formed. Let's use phi to stand for A and A. Again, it looks like we're going to have F if and only if phi, if and only if not C. So we've got two operators within the same bracket. It's not well formed. We're going to need to add in an extra pair of brackets. So that's exactly what I'm going to do. I'm going to add in another pair of brackets here. And that sorts out this particular larger bracket. Now let's look at the other bracket, the wider bracket. So from here to here, we'll allow psi. Sorry, not phi. We'll allow this large bracket here from here to here to be psi. We'd get G or psi or G. And once again we've got two operators, so I'm going to do the same thing. It doesn't matter, we could have done it around the G and the psi, the first G and the psi, sorry. But I'm going to do it around the end ones, so that means I'm going to need to add in a bracket after the G and at the end of this G to make it well formed. So now let's just write that out again so that we can see it a bit more clearly. G or two open brackets F if and only if A and A, if and only if not C or G. Two close brackets. And there we go, we've got a well-formed formula now, and we've sorted out all of the problems there. In no bracket is there ever more than one operator, right? In this bracket here we've just got the caret operator. The next bracket up is this one, which goes from here to here, and we've just got the if and only if. Of course, these two negations, this negation just applies to this formula. Of course, we don't need the brackets. And this tilde just applies to the C, so we don't need any bracketing there. Then the larger set of brackets we've got from here to here, and that's this if and only if. Then this set of brackets, we've got the disjunction, and then finally the largest pair, with this being the main operator. Of our sentence. So that's the one that ultimately decides the truth value of this whole formula. Okay, let's look at one final example. So here we've got small case a and not brackets not phi, or smaller case a, same formula again, smaller case a and not bracket not phi. Okay, well, hopefully you've already picked up on the fact that, or in fact, the foremost thing you should pick up on is that I've used phi here. So back at the very beginning I said metavariables are not a part of PL. So that means that they cannot appear in any well-formed formula of PL. Although they can be used to describe various well-formed formulas of PL, they cannot themselves be a constituent part of any well-formed formula. So here we're going to need to get rid of the phi's, and if we want it to be well-formed, replace them with sentence letters. Similarly, we've got a smaller case A being used. But back up here, what we said is that the only symbols that we use are these as the constants, these as our punctuation, and uppercase letters of the Roman alphabet as our sentence letters. So although we can kind of understand what's gone on here, we know that A is just, this is the lowercase form of this, we're going to need to change it because these just aren't symbols of PL. It's a similar kind of mistake to if you saw written in English, Harry is whatever that says, right? These symbols just aren't a part of the English language. Now it doesn't matter if I could later on give you some kind of translation for this and say, oh well, this symbol is a H, this is the way that we express a vowel. That doesn't matter, it's not a well-formed English sentence because it doesn't use English symbols. So similarly, down here, we need to exchange these for, let's not have them both being A's. Let's have B. We need to exchange these. So let's rewrite that, and we'll end up with B and not A, or B and not A. Okay. Well, taking this formula as it is, there's still quite a lot wrong with it. First of all, again, we've got our negation in brackets. So we saw above that if phi is a well-formed formula, then not phi is well-formed, but we do not need we don't need to add any brackets around phi in order to do that. Yeah, so where this negation is applied, we just don't need the brackets at all. Okay, so let's rewrite again. Sorry, I've missed off a bracket there. I wondered what had gone on. So we'd get B and not A, or B and not A. Now, bear in mind that this looks like quite an odd thing to write. It doesn't seem like we'd ever really be writing out we never say in English it's not the case that, it's not the case that, it's not the case that, it's not the case that Harry is going swimming, or whatever our sentence is. But nonetheless, a string of negations like this is well formed in our language of PL, so that's fine for us to use. Okay, now what's wrong with this? Well, it looks like we've got some superfluous brackets. Sorry, extra one on there. We've got these brackets are obviously needed because they have scope over this symbol here. Similarly, these ones. We've got an outer pair. So if we used phi to represent this bracket and psi to represent this bracket, and to here, we'd have phi or psi, but then we've got this extra pair right here and here. We've got an extra pair of brackets on, and again we can never go from a well-formed formula to that well-formed formula being in brackets. That's just not one of the rules for modifying well-formed formulas. So we need to get rid of that outer pair of brackets. And doing that, we'll end up with B and not A, or B and not A. And there we go, we've got a well-formed formula, because it conforms to all of the rules that we've stated above.